Lesson 4.9. Graph and solve quadratic inequalities. Often in real life, what you're looking for is a range instead of one specific value. An example is how many tickets must be purchased to make at least $500. Well, you want to say, I need 10 tickets. You would say, I would like at least 10 tickets, meaning 10 tickets or more. That means real life often uses inequalities. So we're going to do some graphing of inequalities. Graph the quadratic as if it were an equation. Remember, the vertex is the first thing you have to find. It's the negative b over 2a. It's in standard form. Then you make a table of values, choosing points on both sides of the vertex. So your vertex is the middle of your table. Graph the points, connect the dots. It's a dotted or solid line. It's dotted if it's not equal. It's solid if it is equal. And then you have to shade. You can pick a test point not on the line, and you can plug it in. If it's true, you shade that side of the line. If it's false, you shade the other side of the line. Or the shortcut, if y is greater than your function, you shade above. If y is less than your function, you shade below. So let's graph this one. So first of all, you need to find your vertex. Negative b over 2a. Notice it's the same as the beginning of the quadratic formula. b is 4, a is 1. Fill those in. Our vertex occurs at x equals negative 2. Make a table. Notice my vertex, x is negative 2, is right in the middle. Plot the points. Connect them. It's a solid line because it has the equal to. If it was just greater than, it'd be a dotted line. For the shading, let's pick 0, 0 as a test point. My graph does not go through it. So I fill in 0 for the x and the y, and I get 0 is greater than or equal to 1. Is that true? No. So I shade the other side. You also could have noticed that its y is greater than, so we shade above the line. But what if there's only one variable, such as this example where there's just a p? Well, you make it equal to 0, or 0 on one of the sides. Technically it's an inequality, so it can't be equal to 0. But I move the 5 over. Factor or use the quadratic formula to find all your zeros. So in this case, I think we can factor. Remember, you say what times what gives me the p squared is p and p. And what times what gives me the negative 5 would be negative 5 and 1. Check with the outers, 1p, plus the inners, negative 5p. 1 plus negative 5 is negative 4. It works. So then you take each of those equal to 0, so you get 5 and negative 1. Graph your zeros on a number line. Here's my number line. There's 5 and a negative 1. Notice it divides our number line into 3 parts. Here's 1, 2, 3 parts. Pick a number in each of the 3 parts as test points. So maybe I'll choose negative 2 down there, 0 here, and 6 there. test each of those. So let's plug in the -2. So I plug -2 into the original inequality. And we end up with, if I plug in the -2, we get 12 is less than 5. No. Plug in the 0. So we plug in the 0 for the p, and you get 0 is less than 5. That is true. Let's try the 6. Plug in the 6 for the p, and you get 36. Yeah. You get 12 is less than 5, which is false. I want the middle section there. So that middle section, our answer could be written as -1 is less than p is less than 5, less than or equal to. If we wanted the outside part, we would have if we wanted this area and this area, we'd have like x is less than or equal to -1, and then x is greater than or equal to 5. Or you could solve the inequality in one variable by graphing the quadratic. Make your equation equal 0 and graph it. Let's say it looks like that. When the graph is below the x-axis, that's when it's less than or equal to 0. When the graph is above the x-axis, that's when it's greater than or equal to 0. So if we wanted our function less than 0, we'd have the middle part, because here's where it's below the x-axis. If it was supposed to be greater than 0, then we'd have the two ends. So we'd have this part and this part. And that's all there is today.